Welcome to aminacademy.com. In engineering mechanics, let us do some example problem regarding ladder friction. Example: a uniform ladder of length 3.5 meter and weighing 300 Newton is placed against a smooth vertical wall with its lower end 1.5 meter from the wall. The coefficient of friction between the ladder and the floor is 0.3. What is the frictional force acting on the ladder at the point of contact between the ladder and the floor? Show that the ladder will remain in equilibrium in this position. Now, look at this figure. Here, the ladder is leaning against the wall. Here, the given things. Angle between the ladder and the floor is given. First, length of the ladder L equal 3.5 meter. Here this is 3.5 meter and smooth vertical wall with its lower end 1.5 meter from the wall. Here the lower end is from C to A is 1.5 meter. And the coefficient of friction between the ladder and the floor is 0.3. The coefficient of friction, that is mu, and we can write this AC, the length AC equal 1.5 meter, and coefficient of friction mu equal 0.3 is given. Now here the weight of the ladder equal given 300 Newton. Here the frictional force the coefficient of friction is 0.3 given, and now now we will calculate the forces. Acting on the ladder. Is first we can get it FF frictional force between ladder and floor. Now here RW, frictional force between wall and ladder, is 0, since it is the wall is smooth. There is no frictional force between the ladder and the wall, so we are not considering that one. Next we'll get it RF here. This is RF means reactional force, normal reaction between here. This is normal reaction between ladder and the floor. Now solving the forces vertically, resolving forces vertically, which means the vertical forces means here from the center of the ladder its weight act downward, which is equal 300 Newton, which is balanced by the normal reaction RF. Therefore both are equal. We can say therefore RF equal 300 Newton. There is no vertical forces, only these two forces are there, no other vertical forces, so which is RF equal 300 Newton. Now from the geometry of the figure, here this is it forms a right triangle, so we can say BC, we can find the value of BC equal the square root of AB square minus AC square, which is equal square root of 3.5 whole square minus AC is 1.5 whole square. Let us calculate this. Square root of 3.5 square minus 1.5 square equal 3.162, which is equal 3.162 meter. Now we'll taking moments about the point B. Here the point B is here. Taking moments about the point B, we can say FF, that is frictional forces here. This is FF here. FF into the height of the wall. Here we got it 3.162 equal RF. Here the reactional forces RF into 1.5, because RF is vertical and 1.5 is horizontal, and minus, since it's before it's anti-clockwise, now it's a clockwise moment is 250, that is here 300, the weight of the ladder 300 into half of that 3.162, half of that one. Now we can solve this. Write RF 1.5 minus, we'll calculate this, .3 Newton. This equal 0 here. Therefore already we have RF value, we calculate already, which is equal to 300 into 1.5 minus 473.3, which is equal f into 3.162. Here 1.5 divided by 2, because 1.5 is the width of the distance between the tip of the ladder to the wall. This is 1.5 divided by 2. Let us calculate this. Here it's a 225. Now you can see 300 into 1.5 is 450 minus 225 equal another 225. This is FF into 3.162 equal 450 minus 225, that is FF equal 450 minus 225 is 225 over 3.162, which is equal 71.116, 71.157 Newton. This is FF. We got it, the frictional forces between the ladder to the floor equal, we got 71.157. Now the second condition, will check the equilibrium of ladder. Equilibrium of the ladder means here the maximum force of friction available at the contact between the maximum force available between the ladder and the floor equal 71.157 Newton. Is it is more than that, which is more than the friction available here mu RF is greater than FF, that is 90 is greater than 71.157, therefore the ladder is under equilibrium. We have done.